This is the solution video for exam 2, problem 6. And the first part of this problem asks us to design the AU. And so I need to first figure out what's going on with my AU. And so I look over here, and I notice that I have an AU on my block diagram, and I have R0 inputting into A, and R1 inputting into B. And so I look over here, and I've got R0 plus R0, R0 minus R1, R0 plus R1, R0 minus 1. These are all arithmetic. This is logical, 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 shift, shift. So don't need to do much with those. This is going to be taken care of by my logic unit, seen here. This will be taken care of this. This will be taken care of by this. So R0 plus R0 is my first, so I just need to pay attention to these. So what I notice is that all these share C3 and C2 in common, so these aren't going to pick between them, but C1 and C0 are. So I might as well take care of that right now on this block diagram and put C1, C0 there. That's what's determining my arithmetic function. And so, just doing our usual table, we're going to have A and B. So this is R0 and this is R1, just to keep that in mind. Star, star. Sorry. A equals R0, B equals R1, and C in star. And so 0, 0, 0, 1, 1, 0, 1, 1. So A star, 0, 0 is going to do R0 plus R0, so we'll do A plus 0. Then we're going to need R0 minus R1, so we're going to need to complement this, and then add 1. So A, B complement 1, so we added the 1. 1, 0 is R0 plus 1, so this is A, 0, 1. 1, 1 is R0 minus 1, so A, and then the number negative 1 is just, this is basically R0 plus 1, 2, 3, 4, 5, 6, 7, 8. So all the B's are going to be 1, so this is just going to be 1, 0. So A star is just going to equal A. B star is going to be C1 bar, C0 bar, A, or C1 bar, C0, B bar, or C1, C0. This is a 0. And then C in star is just a XOR, so C1 XOR C0. Now I need to implement the circular shift left unit and the arithmetic shift right unit in the boxes below. And so when I look at this, basically I've got an 8-bit bus coming in and an 8-bit bus coming out. That means I'm going to have to do my shifting outside of the register. So I'm not going to do it directly the way we normally do it. But basically, how would I do this if I was just doing this with wires or in gates? Well, I don't need to AND anything together. I don't need to OR anything together. I don't need to do any logic. I just need to route the wires to the appropriate outputs. So, my A7 in a circular shift left is going to shift back around to 0. I6 is going to shift left to 7, 5 to 6, 4 to 5, 3 to 4, 2 to 3, 1 to 2, 0 to 1. So that's done. And then for arithmetic shift right, 1's going to go and destroy itself. 1 is going to go to 0, 2 is going to go to 1, 3 is going to go to 2, 4 is going to go to 3, 5 is going to go to 4, 6 is going to go to 5, and 7 is going to stay with itself in 7 and go to 6 as well, so that we keep the most significant bit. Now this final question is asking me to complete the data path on the next page. And so when I go back up to here, what I noticed before is this is my AU, this is my LU, this is shift unit 1, shift unit 2, so this is CSL, this is ASR, and so basically the difference between each of these is the C3 and C2 bits, as you notice. So all these are zeros, all these are 0 1s, all these are 1 zeros and 1 1s. Well, basically I just went through every combination based on 2 bits of a 4 to 1 mux. Hey, sweet deal. So I'm going to pick C3 to be my most significant bit, C2 to be my less significant bit, and I know arithmetic unit goes here. This is on the 0 1s, this is on the 1 zeros, this is on the 1 1s. And basically I want these outputs to be stored into each of these registers, so I'm just going to cycle this back up around. So that's done, that's done, that's done, and that's done. And now I'm going to do the loads next, because that's where I'm at in my circuit diagram. So here I'm going to load R0 at these 5 times. So this is whenever C3 bar and C2 bar, so C3 bar, C2 bar, or C3 bar, C2, C1 bar, C0 bar, which I can probably simplify. I just don't feel like it right now. Oh, it basically simplifies down to C3 bar, C1 bar, C0 bar. It's not minimal, but it works. I didn't ask for minimal, so it's not important. R1 is this one, and this one. So this is going to be C3 bar, C2, C1, C0. That doesn't really match with anything. So this is going to be C3 bar, C2, C1, C0 bar. Ordered with these two, so this is pretty much anytime C3 is 1, and really, the rest of these really don't matter. We can put these as don't cares. So this actually is C3 or C2, C1, C0 bar. And then we've got load 2 only happens here, so this is C3 bar, C2, C1, C0 bar. Load 3 should be here, C3 bar, C2, C1, C0. And now I just need to figure out what's being fed into my logic unit. Well, the logic unit is being fed in R0 XOR alternating any between all the other registers. And as we notice, C1 and C0 basically can do that for us. So C1, C0, we're going to put R0 to here and to here. C1 is going to come to here. R2 is going to come to there. R3 is going to come to there. And basically this is going to be my other input to my logic unit. And then, what am I doing? I need to get my circular shift and my arithmetic shift. So circular shift R1 goes into R1 is going to happen. Basically I just need to put R1 into my circular shift left, and I need to put R1 into my arithmetic shift right. So let's just take another branch off of here and branch off of here. And for completeness, you could put /8s on all of these, but I won't take the time to do so.